Welcome to the Daily Space for July 30th, 2018. I am today's host, Dr. Pamela Gay, and I am here to put some science in your brain. The Daily Space is part of CosmoQuest, and I would encourage any of you who have a few brain cells to spare while you're listening to click on over to CosmoQuest.org and work on doing science while I work on teaching you science. So in today's top stories, we have, clicking around, a story that had me particularly fascinated, not necessarily because of its science, but because of the improbable nature of how this science occurred. The variable star CK, I'm going to mispronounce this and I apologize, Vulpeculae, is a star that was seen to come into being back in 1670. For a very brief period of time, this particular star rose to be one of the brighter objects in the sky before quickly fading away. And the reason that there was this sudden brightening and dimming is because what we now see as one glowing object on the sky was once upon a time two separate stars that were flying through our galaxy on what turned out to be a collision course. When these two stars collided, there was, as one might imagine, a mighty explosion. And this particular explosion led to the creation of a variety of different atomic elements. The Atacama Large Millimeter Array has recently discovered that one of the elements visible in this particular, messy nebula, not seen in this particular image of this particular messy nebula, is actually a radioactive form of aluminum. We hadn't previously known exactly where this particular atom might come from, but now we know. Sometimes you do actually require a stellar collision to get certain kinds of radioactive materials created. As I alluded to at the top of this particular segment, this kind of an event is extraordinarily rare. I can't tell you exactly how often because this is, pretty much the only example we have of two normal stars minding their own business and colliding together. So we're just going to have to stay tuned and see what else we can learn and see if we ever have the chance to once again see this kind of a stellar collision taking place. In other news, I have an interesting update on our tale of Martian water. As pretty much anyone who was on the internet may have learned last week, there is radar data indicating that near the Martian southern pole, there may be a sub-Martian, I would normally say sub-terrestrial, but here I, can't, a sub-Mars surface lake of liquid water. Now, the way this was found is one of our spacecraft, Mars Express, in this case a European spacecraft, as it orbited the red planet, took radar soundings of the world, looking to see what is the structure of the ices, the structure of the soils, the structure of the rock. Through multiple passes shown here in the right, they were able to map out what appears to be consistent radar returns with there being water under the surface that we otherwise couldn't see. These radar returns are also consistent with returns that we get through other mechanisms that look for things like neutrons coming from the surface. Now, what's awesome is sometimes a theorist will predict these kinds of things being observed before we ever have the technology to do the particular science. In this case, Stephen Clifford, back in 1987, this is a Planetary Science Institute scientist, predicted that in the past, when there was a much larger Martian pole, that a variety of different features could have led to water ending up being pushed through the surface to form these kinds of a subsurface lake. We see these kinds of features in the Antarctic continent, and the science that allows them to exist there appears to be, perhaps, if Clifford's work is right, behind this new discovery we've made. Now, it is going to take time before this can be confirmed, but what got me reading this particular story was this is a scientist who made a prediction back in 1987 who's still doing science. He is not part of the Mars Express team, but in reviewing their results, he said, this looks like it could be true, and it looks like they're doing all the things right. They're asking other teams, competing teams, other people to interpret their radar results, and also these people are saying, yes, this is all consistent. So this is how we do science. We have people that make predictions who say, as near as I can tell, all the science concludes that this thing is possible. We then use whatever tools we may have, either then or sometimes decades in the future, to go look and see what we can confirm, what we can prove true. And then when we have these results, in this case, results that are amazingly interesting and also extraordinary, well, extraordinary results need extraordinary evidence. And in this case, we have the prediction, we have the extraordinary observations. And now we're looking for those multiple teams to all review them. We're looking for multiple lines of evidence. And I know I, for one, am waiting for the future mission, that InSight's big brother that is capable of digging deeper, seeing more, and maybe, just maybe, getting us a sample of that water. Now, that kind of science is far in the future. The InSight mission, which will be landing in November, is only going to dig a couple of meters under the surface, looking at temperature profiles. And this kind of digging deep mission, we don't have the technology to launch it, fly it, and land it, given the kinds of weight restrictions and sterility restrictions and everything else we'd want to have. But this is something that could be in the future. And this is one of the reasons we keep doing science, is to wait and see what might be possible and what we can discover incrementally, one little bit at a time. And continuing our incremental studying of our solar system, I have further updates on the upcoming Beppo Columbia mission. This is a little spacecraft that is now a collaboration between the European Space Agency and the Japanese JAXA Space Agency. And working together, they're going to be sending a little mission on its way off to the closest rock to the sun. This is a mission that gets to benefit from what we here in the United States were able to do with NASA's Messenger mission. This new mission is going to be launching in November. And one of the reasons I bring it up, even though in general spacecraft are dead to me until they've returned to their first science, is we're looking at one heck of a bunch of science coming in the coming months. And I'd encourage all of you to, well, keep an eye out for how you can get involved in following along with the various missions. We will be bringing you InSight's landing here, if we can, live on Twitch in November. We, as always, when we can, try and bring you the launch of various spacecraft. And right now is an interesting time to get to be part of exploring space. In August, we're hoping to be able to launch the Parker Solar Probe, which will not quite pull a Starship Enterprise as it sinks into the solar corona, literally flying through some of these extraordinarily hot gas, layers of the sun. We are developing the technology to do things we've never done before. and you can be part of all of it thanks to our ability to stream things live and share things out on social media, and thanks to the fact that so much of this data goes out and is made publicly available. So I invite all of you to be part of how we explore our solar system. Here at the Daily Space, we work to bring you the latest news. We are part of CosmoQuest, where we work to make it possible for you to help us do the science. I'd like to thank you for joining us, and I am about to take your questions. As always, CosmoQuest is a multi-institutional collaboration led out of the Astronomical Society of the Pacific. You will see me, Dr. Andreas Plazas, and Joe Myers all on this channel from the Astronomical Society of the Pacific. We're also working with the Planetary Science Institute, where you'll see Dr. Matt Richardson coming on, and we also have Youngstown State University's Annie Wilson joining us on the stream periodically. Please give us a follow. It will let you know whenever we go live to put more science in your brain. We are sustained by your subscriptions, and every little bit matters. And I see some delightful bits coming in now. Can we light up the stream with all those rockets to celebrate those bits from Trekker Kev? So do we have any questions, anyone? If you can go ahead and at me, that makes it far easier for me to find your questions. So here I am, waiting to see what you have to ask. This week, while you're typing those questions in, I will be bringing you the Daily Space, Monday through Friday. Same time, same channel, every day, 1 p.m. Eastern, 6 p.m. London, 10 a.m. Pacific. We will also be hosting Learning Space this Thursday evening. I still need to wait and see exactly who our guest is going to be. In addition to that, I'm going to be doing office hours Tuesday night, and we will be having Dr. Matt bringing you Astro 101 Wednesday and Friday, directly following the Daily Space. Oh, I'm not seeing any questions today. I'm guessing it's just that kind of a quiet Monday. So there's Hanny asking, when two normal stars merge, do they become one star completely, or do the cores not come together? It entirely depends on exactly how the two stars come together. When I hear things like what happened to our friend CK over here, and let me bring that image back up. When I hear collision with stars like CK Volopeklia, what I'm hearing is these are two stars that did not merge politely over time, but rather vectorially rammed into one another, more in the way of a car crash. When this occurs, you end up with much more of a nebula surrounding the objects and a remnant rather than a resulting star. Now, there are other cases where we have stellar mergers where the stars slowly spiral together over time. In these kinds of cases, we can end up with stars like the blue stragglers that we see in globular clusters, that are cases where the two stars are much more likely to slowly merge envelopes, to have their cores come together, and they truly become one star in the end. Now, all I can tell you is we have theoretical models for how the cores may or may not merge politely over time. We don't yet have the ability to dig down into a star and get you specific data. It does, however, look like there are cases where stars are able to politely merge together through this spiraling in kind of behavior. So, Hanny, we can get explosions from these kinds of mergers, especially where we have what's called stellar cannibalism that occurs in the lead up to the merger. This can occur where instead of having two regular stars like our sun coming together, we have one that is a high mass object, a high density object like a white dwarf star that may pull matter off of its companion, and as that material becomes exceedingly dense, it undergoes nuclear reactions and small-scale explosions. We can also end up with type 1a supernova, where instead of, merging, that smaller radius, higher density, higher mass star simply explodes, leaving us a supernova remnant to follow. Looking to see what other questions we have. Hey, Michael, it's good to see you in the chat. Good to see all of you in the chat. It's true, Larry. Rough mergers, well, I don't know if they make the most noise since space is mostly a vacuum, but they certainly get the most media attention, most telescope attention, and produce the most high-energy particles and photons. Yeah, noise in space, not so much. You're right, Guido. Do we have any other questions out there? So while I wait to see, there we go. Larry is saying, think of the new isotope of CK and helium. Are any other elements first discovered spectroscopically? I don't know the answer to that, but I'm pretty sure that other things have been found spectroscopically first. I just don't know what. And here we have to remember that when I say found spectroscopically first, I don't mean that they were necessarily found in space. They could have been found in a laboratory where it was simply that lab chemists saw the distinctive emission and absorption lines in a burning element that meant that that particular burning element wasn't anything that had been seen before. So Ed is saying, I apologize if you've answered this, but I arrived late. Is there a nearby observable through a telescope pair that looks like they may merge politely? Not that I know of. That doesn't mean that there aren't, but not that I know of. There are, however, a variety of cataclysmic variables. These are stars where one is that high density, low radius, white dwarf star. These are stars about the mass of the sun and about the size of the moon. There are many of these that are near normal stars, massive stars, sucking that material off and periodically flaring up in brightness. These can often be seen either naked eye or through small telescopes, and you can get entire lists of them to follow from the American Association of Variable Star Observers. Michael is asking, are you still pleased with your new computer? I am indeed, for the most part, still pleased with my new computer. As some of you may know, the computer that I use to record from this location bit the dust about a month ago now, and was temporarily replaced with a 2017 refurb. And last week I received an i9 laptop that I was able to replace it with. It runs hot. It's currently running at 166 degrees Fahrenheit, and little fans are blowing. But you know, it just gets it done. And with a computer, sometimes that's all you need, is for it to get it done. So Larry, this is the new MacBook Pro that just came out. The fans are quiet, but I can still hear them. So yes, these are the things I deal with. So Carolyn is saying, thinking about what the Earth looks like from the moon during a lunar eclipse. Are the city lights visible from the moon? Yes, city lights here on Earth are visible from the moon. Now, during a lunar eclipse, you get to be on a part of the moon that would otherwise be experiencing day. And as you're hanging out thinking it's going to be another 15 days until darkness perhaps comes to your region, depending where you are on that lunar surface, suddenly the Earth's shadow gets in the way of that sunlight. And as you look down, well, you were already seeing the Earth's city lights. During a lunar eclipse, nothing happens to the Earth that causes those city lights to go on or off in a way that they aren't already on or off. But what you experience that is new and different is you no longer have that sunlight shining on your solar panels, which is usually the most critical part. And so you get to experience this few hours long darkness, and it's different than what you would normally experience during a lunar day. This is more to a lunar dweller like how our solar eclipse is here on Earth. So looking to see what other questions we may have. Hey, high speed SRAC. Do we have any other sciencey questions? Yes, the galactic center is annoying being in the south. I agree with you. As someone who lives in northern latitudes, it's always been annoyingly close to the horizon, and along with it, our galaxy center is located in the constellation Sagittarius. And along with being home of the sky position of our galaxy's center, it's also home to a whole bunch of beautiful nebula and star clusters and dark patches and dusty objects. And for those of us living too far north, all of these objects can be hard to see. I'm sorry that some of you had overcast during Friday's eclipse that I know was streamed out from many locations. It would be amazing to see the galactic center at zenith. Things to try and do someday in the future for me. We do have, if you're particularly far north, the ability to see aurora, your right Paranor. For those of us that live at mid-latitudes, we get the best of neither world, however. Sagittarius likes to sit fairly low in the sky, and the aurora don't seem to quite make it this far south. I'm so glad, Astro-wise, that Fraser was able to stream that. I do admit I took a vacation Saturday and Sunday and left early in the day on Friday, so I skipped town and missed the eclipse. Vacations happen, although I'm not sure they're called vacations when it's only on the weekend. So do we have any other questions out there? If not, I'm going to remind you I will be back same time tomorrow, 1 p.m. Eastern, 10 a.m. Pacific, 6 p.m. London, and I will be working to bring you more of what's new in astronomy and space science. I am today's host, Dr. Pamela Gay. This particular show is also hosted by Dr. Andreas Plazas. We take turns as we take opportunities to go to other places, bring you science, not always in the same language, not always at the same time, and sometimes even face to face. So stay tuned as we work to keep bringing you the show every Monday through Friday, except for major holidays. This is a reminder, we are now roughly 3 weeks away from the start of the International Astronomical Union meeting in Vienna, Austria. I will be there, and I will be, internet Wi-Fi willing, from Austria, working to bring you the daily space and a daily update from IAU when that happens. Give us a follow, get the word out, help people know that we are over here bringing you science on Twitch. Every follow gets you updates on when we go live, and we rely on your word of mouth to build our audience and make more things possible for us here on Twitch. So thank you all for joining me. Once again, we are part of CosmoQuest. Go to cosmoquest.org, where you too can help us explore our solar system and even our planet Earth. So thanks for joining us, and I will see you on the other side. Wherever in the world you may be, remember to have a fabulous morning, evening, or afternoon, and go outside and look up. Bye-bye.